Hey guys, welcome back. So today we're working on the 7,000 watt Champion generator. This machine was rescued from the trash by my friend Jason. So unfortunately, neither of us know the history on this machine or why it was thrown away. That said though, it appears to be in very good condition. There is no rust, no damage, no missing parts. And the engine, it does rotate and has very good compression. So this engine should run. So that just begs the question, why was it thrown away? You know, from looking at it real quick, there are only two clues. I guess first off, this is electric start. Battery is stone cold dead, so no surprise there. But the electronic choke has been disconnected and the OEM carb removed. Instead, we have a Honda clone with a manual choke. So someone went to the trouble to swap that carb out, and yet it still ended up in the trash. So my hope today is that we can get this up and running again. So let me get you set up a little bit better and get going on this. I'm not sure how well this shows up, but we're not out of oil. If you look real close, there is a line right down there, but we are very low. You know, the oil is actually supposed to be right up to the last thread. So potentially this engine is burning oil, or maybe it just ran low due to normal use. You know, either way, with the oil that low, it could have actually been tripping the oil sensor and shutting the engine down. So potentially all we need to do is add oil and this thing will start to run. Since it's so low, you know, we might as well drain out what little is in there and just start with all fresh oil. But before I do that, you know, I do want to test the oil sensor. You know, we can use a multimeter to see if it's tripping right now due to low oil. And I suspect that it's not, because with the engine off, you know, the oil is puddling down on the sump, and likely that low oil sensor is satisfied. But I'm thinking as soon as it starts running, you know, that oil is going to splash around and the sensor is going to shut the engine down. So, you know, we'll test this right now. Likely it's going to come in fine. So then we'll drain the oil and just see how much comes out before we trip the low oil alarm. All right, I've got the multimeter set to measure continuity, and I'm going to put one lead right here on the yellow wire. And we'll put the other one on the engine ground. Now, when I connect this, it shouldn't beep if we have enough oil. And right now it is not beeping. So let's get the oil drained and we'll see how much comes out before that alarm trips. Huh. Not much coming out of there. There we go. Well, the oil looks clean, but it's going to take a while at this rate. So let me find something to weight this down, and then we'll give it a bit of time. It's definitely some thick oil. It's been half an hour and it's still coming out. You know, there's not much left in there, but we'll give it some more time. You know, the low oil sensor hasn't tripped yet, but it should if it's working properly. As far as I can tell, all the oil is out of the engine, and it took quite a while. It's actually been, I'd say, over an hour and a half at this point. So even with the oil drained, you know, we're not sensing a low oil condition. So potentially the switch is broken, but I'm thinking more likely it is just stuck. It's actually a float, and a pretty lightweight float at that. So, you know, if it gets gummed up by some thick oil, then that float is not going to drop. So I'm thinking once we get the proper oil in here and get some heat in the engine, likely it's going to come back around. But before I do that, I'm thinking let's just tap the block a few times and see if we can get that float to drop. So I've still got this set to measure continuity, so it should beep, assuming the float drops and works. So we'll just shock the block a few times, see if we can get that float to drop. And no, we're not getting anything. That said, though, I'm not too worried about it given how thick that oil was. So we can circle back on this later once we get some heat into that block. This engine takes just over a quart of oil, which is 1,100 milliliters. And there's really no need to use the dipstick. I can see we're right up to the last thread, more or less. And the oil's so clean, I'm not sure you can see it, but it's right just about full, a touch below. So that should be fine to test with. And I think we're just going to end up draining the oil anyway once we get some heat in the engine. And let's see how much oil was in that engine. Should have been 1,100 milliliters, which is essentially to the top. And there was actually more in there than I thought. Quite a bit more. And it looks brand new, like the engine has never run on it. So about 700 milliliters, maybe a little bit over. So yeah, not too bad. It was only about 400 milliliters low, but I'd say well in the safe zone. So I'm going to do the easy thing here and swap this battery out. I do have another brand new on the shelf, which is a direct replacement. So we'll get that installed and then turn our attention to the fuel system. I want to see what we're dealing with here. I don't know if we have engine problems, generator problems, or maybe no problems at all. Maybe it was just user error. Just going to clean these terminals up a bit. This one isn't too bad, but the negative looks a bit worse. And we are missing the tie down, so I'm going to add a strap to just keep it firmly in the tray. All right, let's try it out. Beautiful. I did find a date code on this machine. It was actually made in July of 2013. So this is about 12 years old. And I'm also noticing we still have the new generator tags on it. So I'm assuming that this was a low hour machine. Anyway, let's see what we're dealing with as far as fuel goes. According to the gauge, we are empty. And yeah, we got a bit of rust, at least on the fill, but the bottom of the tank isn't too bad. There is a little bit of rust, a little bit of fuel. Yeah, I'd say the fuel isn't fresh, but it's definitely not bad. So, it hasn't been too long, I would say, since someone tried fixing this. Anyway, I did notice the fuel valve, it was left on, so the carb, it's been marinating in that fuel for a while. So although the carb was replaced, we may potentially need to clean it. I'm thinking for now, let's just bypass the tank. We'll drain out whatever's in the carb. We'll put some fresh fuel in there and try to fire it like that. So hopefully this fuel valve works. Guess we're going to find out. And yeah, seems like it's working. So the tank, it is bypassed. Another good thing to check while we're here is just the throttle plate. These machines, the resting position is wide open throttle. And if the throttle plate gets gummed up, it may not move. And if you got to start the machine, it could rev out of control and damage the engine. So it's always a good idea to move the governor arm and make sure we're not bound up. And in this case, we're moving, but actually, the governor rod is not connected to the carb. So like that, this machine would run at wide open throttle and not be able to slow down because the anti-surge spring, it is connected, and that is enough to hold the throttle plate wide open. So we do need to correct that issue before we try to start it. So let's do that now. And then we'll get that carb drained out. So it's interesting that this is disconnected. It makes me wonder, did it happen after it was thrown away, or is this the reason why it was thrown away? Because with this disconnected, the governor would have had no control over the engine speed, and it would have been revving at max speed. So now we should have control of the speed. Anyway, I'm going to leave the airbox off for now. I'm just going to bolt this down as is. Likely we're going to have to pull this anyway to clean it up. Yeah, it looks like there is some water down there. So like that, this carb would not have run. The water cannot get pulled through the main jet, but the bolt for the drain is actually very clean. So that is a good indicator of what the rest of the carb looks like. So I'm going to get this back in. We'll just try filling it up with some fresh fuel. And I'm willing to bet this carb is going to run the engine. Probably zip tie it right there. Okay, carb accepted fuel, and the needle shut off the flow. So let's give it a try. All right, let's give this a try. I've got a light plugged in and turned on. We've got a good battery. We have oil, fuel, and a governor that's connected. The choke is on. So let's try to start it. Well, that was something. The engine, it runs, it sounds good, and we're making power. So everything that needs to work is working. The governor also controlled the engine speed. Now, we are having some run issues. It took a lot of cranking with the choke on before it would start. And as soon as it started, I turned the choke off and the engine went to stall. So I turned the choke back on, but the engine did not recover. So I would say likely it is a fuel problem. Potentially it is a spark problem, but I'm thinking, for now, let's refuel and try this again. All right, we are refueled. It didn't take a whole lot, so it didn't actually run out of fuel. I think it's just a fuel delivery problem with the carb. So choke is on. Let's try this again. And we get nothing. And this time we have no signs of life. So I'm actually thinking it might not be fuel related. Potentially we're dealing with a spark problem. So let's get the spark tester on there and check for spark. I'm going to crank the engine with the choke open. Likely it won't start, although I guess it could if we have fuel and spark. So let's see if we have spark. And no, we had it for a second and then we lost it. So I'm going to unplug the oil sensor and we'll check for spark again. All right, let's try it again. The only difference is this time the oil switch is unplugged. That's all it was. So it seems like that oil switch is in fact bad, because when we drain the oil, we didn't get a low oil indication on the multimeter. And with the oil sensor plugged in, we lost spark. So it's kind of acting poorly. But now the engine should start and stay running. So let's try it again. All right, let's try this again. And that's all it was. So there is a bad oil switch on this machine. So with that bypassed, the engine starts and stays running. Although that said, the carb, it is having issues. I did have to keep the choke on, most of the way for it to run smooth, but it did run smooth. Everything seems to be good. The voltage, the hertz, and according to the meter, not that many hours on this machine, about 151 hours. So yeah, not too bad. So we'll start with getting the fuel out. And then we need to get the fuel solenoid off to access the bowl nut. Now, the fuel that's coming out, it actually is pretty dirty. It has water. So that is interesting, because the fuel I put in there was good, clean fuel. So I'm thinking last time I drained it out, likely I didn't get all the water out. And the fact that it's dirty, despite what the bowl nut looks like for the drain, I would say, it is dirty in here and definitely needs a good clean. It's not too bad. Tiny bit of buildup, but overall it looks pretty good. Looks brand new. So this also looks pretty clean. The float looks good. Bowl looks very good. So yeah, I'm not sure cleaning it is going to solve the problem, although the water, that might be the whole problem as far as why I had to run it with choke. The other possibility too is that this engine, it is larger than most Honda clones. These clone carbs are usually good for engines that are 389 cc's up to 420, and this one is, I think it's 438. So the jetting potentially has to be swapped out. But for now, we'll give it the benefit of the doubt. We'll clean it up and see if it improves things at all. We also have an adjustable pilot needle right here, which looks to be pretty far out. Let's see where it's set to. Actually not far out. 1 1/4 turns. And we have the main jet down the center, as well as the emulsion tube. So let's see if this comes out. Yep, it was tight. Okay, and that's everything. So this carb appears to be in very good condition. So definitely viable. Potentially it might need to be rejetted. But let's just clean it up, see if that makes any difference. So pilot jet was not clogged, and neither is the main jet. Emulsion tube looks great. All right, the carb's all nice and clean. Of course, it wasn't that bad to begin with. So I am cautiously optimistic here that this might run right. And while this was in the ultrasonic, it kind of hit me as far as where the water came from. I actually reused the fuel line that was attached to the carb, so likely that had some old fuel and water in it. All right, we'll get the emulsion tube back in. Main jet. And we'll get the pilot jet in, making sure that it's fully seated. And this one isn't wanting to drop down, so I'm going to put a little bit of WD-40 on there to help it out. There we go. Then a spacer goes on top. And the idle set screw is used to hold that pilot jet in place. And on most machines, this would also set the idle speed, but this engine does not idle. So only turn this until you see a couple threads coming out the other side like that. And then we just have this pilot needle. So it was 1 1/4 turns out. So I'm going to lightly bottom it out. And then we'll set it back to 1 1/4. All right, right there, we're bottomed out. 1/2, 1, 1 1/4. So I'm going to bolt this back onto the machine, and I'll turn you back on in a second for the test. I've got the carb bolted back in place, and I have refueled, and the needle seems to be holding steady right about there. So let's crank the engine, we'll get it started, and with any luck, we'll be able to turn that choke off right away, and the engine will run nice and smooth. So yeah, this carb, it is not cutting it. It cannot run the engine with the choke off. And given that we're not running under load, likely the problem area is the pilot jet. Now, we do have an adjustment right here, this pilot needle, but it only controls the amount of fuel on one of the passages in the pilot circuit. And in the throat of the carb, there's actually 4 or maybe 5 passages. And this right here is a very fine adjustment. I don't think it's going to solve this problem. So I'm going to start just by pulling the pilot jet out. We'll leave the carb on. We'll just measure it up, see where it's at, and either drill this one out or potentially just find a larger one from a parts carb. So I'm just trying to find the biggest drill bit that fits. And it looks like it's this one right here, which is our number 78 micro drill bit. So I'm going to drill that up to the next size, potentially 2, because it's not even close to running correct. So yeah, let's use a 76 drill bit. And we'll see if that makes any kind of improvement. And one thing to keep in mind too, you probably don't want to do this unless you have extra jets. You know, these drill bits can break in the jet, and when they do, the jet's pretty much done. You know, you can also over drill it. Like in this case, I'm going up 2 sizes. So if that ends up being too much, you know, you're going to need to swap the jet out with one that wasn't drilled out. So it looks like we're through. So I'm going to put this back on, and we'll see if it improves the situation. All right, let's try this again. The drilled out pilot jet is reinstalled, and we are topped off with fuel. So maybe, just maybe, this time it'll run a bit better. So definitely a noticeable improvement with the drilled out pilot jet. That said though, you know, we've drilled it out 2 sizes. That should have cleared up the issue. And even like that, you know, when I turn the choke off, it is surging. It is still starving for fuel. So I'm kind of wondering if there is just an internal blockage or potentially a manufacturing defect on this carb. So I think rather than continuing to drill that jet out, you know, I'm thinking let's put on another carb. You know, this one is a used carb, condition unknown, but it looks to be in very good shape. And I checked the pilot jet. It is actually the original size that one was. So it'll be interesting to compare how this one runs kind of with the stock jetting versus the one we drilled out and still not running quite right. So I'm going to take that one off. We'll throw this one in its place, see if it does any better. So I am using a new gasket. The other one looked fine, but it was actually stuck to the other carb. So we'll just leave it where it is, because pulling it off likely will damage it. All right, I've got the different carb installed with the original pilot jet size. So is it going to be the same result or a different result? Let's see. That was a pretty noticeable difference. This time when cranking the engine, it actually started quite a bit faster. You know, I was able to turn the choke off and things ran perfect. So this carb, I think, is the winner. You know, I'm going to leave this on the machine, and this one is going right into the parts bin. You know, I'm not sure what was wrong with it, It looked pretty good on the inside, but clearly it has a problem. So I'm going to get the airbox back on, and then we can move on and finish this up. So we'll get rid of this test line, and I'm not going to reuse the old line. I'm going to put a new one in its place. I'm going to take this choke control off. There's really no point in keeping it on the machine. You know, the carb that's on there doesn't accept it. Now, you could potentially buy an OEM carb, in which case this could be used. But given we don't have the remote, and I don't think those are available for sale, there's really no point in changing things up. We'll just get this removed. You know, I think the machine will work without it. We'll try it real quick. And then I'm going to use these hold downs that are being used for this servo to actually hold down the wires for the fuel solenoid. These hold downs are pretty neat. They're just split in the middle, so you can put whatever it is you're trying to secure right through it, and they just snap in place. You know, they hold the wire pretty good. The tank shouldn't be that hard to clean up. It's not really in that bad a shape. Really, we just need to flush the water out of there. Obviously, there is some, because we saw evidence of that in the carburetor. And there's a bit of loose rust. So once that's cleaned out, we'll just double check the fuel filter and make sure that it's good. And at that point, you know, we'll be ready. You know, of course, that doesn't solve the problem here with the oil sensor. You know, I think most people would just leave it disconnected, and you can run it like that without issue, as long as you check the oil. And I know from experience, a lot of people don't do that, and they end up blowing up their engines. So to get a new oil sensor or float, they're not that expensive, about $9 on Amazon. I think about $11 from Generac. So it's not the cost of the part that's the issue, it's getting to the part. You know, to get access to the part, you do have to remove the generator, the exhaust, and probably the battery, just to give yourself some room to work. So I did order it. It'll be here in about a week. So I think for now, I'm going to roll this into the corner. When the part arrives, we'll get it installed, and hopefully that brings this back to 100%. Well, it's been close to a month, and it was pretty hard to get this oil sensor. Originally, I ordered a Generac part, and after a few weeks, I realized it was on back order. So instead of waiting any longer for that part, which may or may not show up, I ended up doing what I said I didn't want to do, which is just order a generic part, in this case from eBay. The guy I bought it from, I've actually bought a lot of clone parts from, and I've had pretty good luck with those parts. So, that said, just because the part's new doesn't mean it works. So I thought I would test it using the multimeter, similar to how we did on the machine. We're set to measure continuity, and when these leads touch, the light lights up, the alarm sounds, and it shows a low resistance on the screen. So with that in mind, we just put one lead here on the yellow wire, and the other lead goes on the back. There is a metal contact right there where it should pick up the engine ground, and when the float goes down, that should complete a connection, and we should hear this beep. So by holding this here, the float right now is sideways, so we should get nothing, which we don't. And then when I flip it upright, we should get a connection. But we get nothing. I hear that float moving around, but there is absolutely no connection between that terminal on the back of the float and the yellow wire. There's nothing. So yeah, this, although it's new, doesn't mean it's good. And in this case, this float, definitely not good. So I scrounged around. I was pretty sure I had a used float, and that was not my first choice. But given the difficulty of getting one of these, I thought I would try this one out to see if it tests well. And the fact that I saved it is probably an indication that the float is still good. So if we do the same test, one lead on the yellow wire and the other lead here on the contact, right now we should have nothing, so the float's upside down. But when we flip it upright, we get a connection. And it's very consistent, low resistance. So although this part is used, in this case, it is the good part. So I'm going to go with that one. So let's get the engine oil drained. We'll start taking it apart and fit it with a new oil float. And this machine is actually one of my favorite clone generators. It has kind of a lot of bells and whistles without going overboard. It does have remote start. Of course, I never get the remote, so I haven't actually tried that out. But it also has over voltage protection, which is nice. It'll shut things down if things go crazy. I think it also protects against an overspeed issue. And on the oil change side as well, there's no bolt to speak of. There's actually a hose right here that's fitted to the frame. So you just pull that off, put the hose in the tray, and the oil comes right out. This might take a while. The engine's cold, and you can see how slow it comes out. So yeah, this could take a good 30 to 40 minutes, I would say. So yeah, it's going to take a while. So while that oil is draining, I'm going to start taking the machine apart, starting with the tank. I want to get that out of the way. It's just blocking access to the stuff we need. Once that's gone, we can start working on getting that generator removed from the engine. Well, before I get the exhaust fully off, I'm going to get this handle out of the way. It's kind of interfering with the stator as far as removing it, as well as clearance for the exhaust. So we have a snap ring on each side, and then we should be able to pull these pins out, get the handle out of the way. And we'll get a little bit of penetrating oil on these. They do look a little crusty, so hopefully they come off. Okay, that one wasn't too bad. All right, I've got you resituated here. My daughter wants to try to get off this remaining nut. She's going to use all her strength here. There you go. That wasn't too bad. Now you can, or I can spin it out with my fingers. Maybe I can't. All right, keep going with the wrench. So we've got the exhaust out of the way. I also pulled the battery just to make some more room. And at this point, we're pretty much ready to pull this generator off. So I'm going to get the end cover off. We have to disconnect all the wires running up to the control panel. And then we can remove the stator bolts, remove the stator, and finally the rotor. Okay, so we're going to get the AVR out as well as the brushes. We need to disconnect all the wires. And this AVR has an extra connector as well. I believe that's for monitoring, most likely the voltage output up at the control panel. But I'm not really sure. It's not documented, and it's pretty unique to this machine. And we also have an auxiliary winding here. So we'll get that disconnected. And then we just have these 3 wires that run up to the control panel. So we'll get those out and also loosen up the wire block. We need to get that out of the way because ultimately we need to get a puller in here to pull the stator off the bell housing. And just take note too, the wire colors don't necessarily match. We happen to have a red here on both sides. The white connects to the blue, and then we have black to black. And I'm just going to put all these washers and split washers back. And actually, I'm going to put all the bolts back loosely where they go. That way there's no question when putting it back together. And I won't lose any parts. Okay, everything that needs to be disconnected is disconnected. So we're just going to free up the end housing by removing the 2 bolts. We'll get the stator bolts out, and we should be ready to pull this off. Okay, that was actually attached to a stator bolt. So I could have waited to do that. All right, we'll get a little bit of penetrating oil in here to help the ball bearing come out. And now we're going to use the puller. And this is a small puller. It can break this end housing very easily, so go easy. If you feel the force building, you need to stop and kind of rethink how to get this off. I don't like the feeling I'm getting. There's a lot of force there, so I'm going to tap around the bell housing with the hammer. We'll try this again. Don't trip. So I'm going to try to shock the rotor off the crankshaft. This usually works pretty well. The only catch is don't pretzel this bolt and also don't miss. So you're going to destroy a perfectly good rotor. Oh, I think that did it. And at this point, we can get the end cover off and do the work that we need to do. But I am thinking it's going to be a lot easier if we just get the engine completely off the frame. So there's only 2 engine mounts left, 1 on each side. And we also have some wires coming down here from the control panel connected to the engine. They're kind of hard to see, So I'm not sure I'm going to record that, but I'm going to get those wires disconnected and probably get the airbox off as well, because these tend to kind of drag on the ground once you have the engine off, and you're going to end up doing a bit of damage. So we'll get this off, get the wires disconnected, and pull the bolts. The engine should come right out. All right, so we'll get the fuel solenoid unplugged. And then we have this black wire coming from the control panel. This is what runs over to the coil to kill spark. Okay. And then we've got a couple more here. It looks like heading over in the direction of the starter. And the remaining wires, you can just get a glimpse of them here. It's kind of hard to trace where they're going, but we have, looks like a white wire going into a black, so we'll get that unplugged. Got a brown to a brown. And that one, ooh, that one does not want to let go. We'll come back to that. We've got another white to a black with a white stripe. And I think that's just about it, besides this brown wire. Let's try to get this out again. No. There we go. So there's still one wire left connected directly to the starter, and there's really no way to get to it with the control panel in place. So I'm going to pull these 4 bolts, and really this thing should be free with the exception of that one wire. So we'll kind of set it out of the way, disconnect the wire from the starter, and at that point we should be free to get that engine out. And it's right here under this cap. It's going onto the red wire. So this is likely power for the charging system. And that right there is what we came to get. So we can actually remove that or swap it out without pulling any of the gears. But I'm going to pull the gears anyway because I need to clean up the gasket. It's going to be a lot easier with the gears out of the way. And there's also a surprising amount of sludge down here on the bottom. So I want to at least get that cleaned up as well while we're here. So I'm just going to back the engine up till the timing marks align. And then this should come out pretty easily, the camshaft. And the lifters might fall out, so we'll probably just take them out so we don't mix them up. But by doing that, the push rods are actually coming out as well. So we're going to have to pull the valve cover to get the push rods back in properly. And we have to rotate the engine a little bit more for the counterbalance shaft timing marks to align, which is right there. And I'm going to keep rotating the engine. I want to get this dipper out of the way. It's somewhat delicate. You don't want to bump into it with a tool because you might break that off. So yeah, the oil sensor, it does seem to be damaged. Usually there's a cap on the bottom, kind of like the one we're going to throw in there, but I'm not seeing any evidence of that cap, so I can only assume that the engine must have chewed it up. Anyway, the one we're putting in there, it is a little bit wider for sure than the one that's coming out. The bolt holes I think are going to line up. So let's get it fitted and just make sure this is going to work. And yeah, I think that's going to be fine. So I'm actually going to pull those bolts back out. I want to put a little bit of thread locker on them, and then we'll torque them down to spec. And actually, I'm just going to pull the whole sensor out first. We'll get the sludge cleaned up, and then we'll do the permanent install. So get the camshaft and the counterbalancer back in. So the timing mark for the camshaft is right there, corresponding one on the gear there. And actually, before we do that, let's not forget the lifters. Okay, those timing marks are good. And that's the timing mark there for the counterbalancer. So we'll rotate that around. To right about there. And the timing mark on the counterbalance is right there. And this gets torqued to 216 inch-pounds. So I'm going to bring it up halfway first, and then we'll finish it up. So it looks like it's going to be a little tricky just to get the push rods in without first pulling the rockers off. So, you know, this design is a little bit unique. I haven't seen this before, but I think if we just take these nuts off, the rocker should lift out of place, and then we can get the push rod installed. Before I do that though, I'm going to remove this rotator cap. You know, this could fall off and go down into the engine. So we'll get that out of the way before we hit this with an impact. All right, let's check the valve clearance. We are at top dead center. Usually on these engines, it should be 6 thousandths on the intake and 8 on the exhaust. In this case, 6 fits with pretty much no drag. Let's try an 8. A little bit of drag, and I'm thinking it's probably close to a 10. Yeah, a 10 actually has too much drag. So the intake is probably a 9. And the exhaust should be closer to an 8. Let's see where that's at. No, the exhaust feels tight. The 8 did not fit. Let's try a 6. And the 6 is actually kind of loose. So I'm thinking we're a 7. So yeah, the exhaust, that's within spec. You know, I would say 8 thousandths plus or minus a thousandth. So no issues there, but the intake, that definitely needs to be tightened up a bit. All right, that feels pretty good. Tighten it up just a bit. And often the clearance changes as you snug that lock nut up. And it still feels pretty good, maybe a touch loose, so we'll try to adjust it a little if we can, but we can't unless we loosen it. All right, and right there it feels too tight, but I think when I tighten up this lock nut, we're going to get some of that back. Yeah, and it is loosening up. So the 6 fits with a little bit of drag. And the 7 doesn't fit at all. So that should be good. Just make sure that's snugged up, which it is. We'll double check the exhaust. Yep, that is tight. So the valves are good. So before we go much further, I'm going to add oil back to the engine. And really what I'm curious to see here is that the oil sensor functions. I mean, right now we have no oil. We have a low resistance connection, 0.8 ohms. And I've measured out about a liter of oil. So I'm going to pour this in. And I'm curious to see how much it requires before the sensor is satisfied. So right there, that's about 500 milliliters. And right there, it just went open circuit. So we actually put in quite a bit. We only have about 150 milliliters left in here. And the oil, it's almost full. And I'm going to get the starter recoil off because the rotor needs to be torqued to 30 foot-pounds. And with this off, I can put a wrench on the flywheel nut and hold the crankshaft still. So while we're here, I'm going to clean up the slip rings and also the outer race on this ball bearing. It is a little bit rusted and pitted. You know, that's likely why this was a little tricky to get the end housing off. So we'll clean that up as well. And it should go back together quite a bit easier. So I'm going to get these bolts in loosely and then actually pull out that piece of wood because the stator, you know, it can go on pretty much any way it wants to. And you want to make sure that these feet are in such a way that they rest properly on those mounts. So by putting these bolts in, you at least know you're pretty close because these should be straight across. And then when you drop it down, if it's not perfect, it'll straighten out. So before going any further, now that everything is torqued down, you should rotate the engine and just make sure that nothing is binding up, that everything is aligned properly. You don't want the rotor to make contact with the stator. So right now I do have the spark plug out. The starter recoil is still off, but I'm just going to rotate the engine with the starter cup. And it does rotate freely. You know, I don't hear any scraping, no binding. So I think the alignment's good. All right, let's see if we remember how these go. And the good news is a lot of these were color-coded. I know that black goes to black. That kills the spark. We have these wires here with the green and white, which connect over to the fuel solenoid, which we might do that after because we're a little bit short. So we'll just take those and put them off to the side. We've got the yellow wire, which is the oil sensor that goes up to the control panel. And then it looks like we have a coil behind the flywheel. So that is a black wire coming out. And let's see what we have for choices here. We actually have two white wires, one with the green stripe, so that's the solenoid. And then we have a white wire and a black wire with a white stripe. So luckily, only one of these wires will fit. So it has to be that one. And then we have two wires here for the solenoid. And we only have one wire left, so Yeah, we have a brown wire, which I thought went to brown. But maybe I'm wrong, because we only have 2 wires from the control panel coming down and 2 left here on the solenoid. And it looks like we can only plug them in one way. So we'll get that connected there. And that connected right there. And then we have the wire that runs over to the starter solenoid, which is going to be battery positive, and also the charge wire. And I was just double checking my work and I found the mistake here. I thought it was brown to brown, but I didn't see a brown on the engine side. But after looking a little bit closer, this one is sleeved with a black sleeve, but underneath it is brown. So I need to disconnect that, move it over to the brown wire that goes to the control panel, and then connect the black with the white stripe to the white. Good. I think that should do it, at least on the engine control side. So I'm going to get the control panel mounted back on, and then we'll wire up the high voltage side of things. Looks like this shrink tubing right here, it's coming too far down. You can see it was pinched. So I'm going to trim that back, probably trim that one back as well. And the leads coming down don't look great, but I think we can get away with leaving those alone. Actually, that one looks pretty good. So before I get this, I guess, fully back together, I'm just going to test the neutral wire and the ground wire to see if they're tied together. You know, sometimes they're bonded. Actually, a lot of times they're bonded on a portable generator, but sometimes they're bonded down here and other times up at the control panel. So it's not always obvious if it is or is not bonded. So I'm just going to use the multimeter set to test continuity, so you can hear when the wires are connected. And what I want to see is if the white and the ground are bonded, and they're actually not. So this is a floating neutral generator, which is kind of an odd setup for a portable generator. Usually you want it bonded if you're using it as a portable generator, but if you're using it to connect to your house, then this is exactly how you would want it. So I'm going to leave it as is. You know, most likely that's how it's shipped from the factory. So we'll do red to red, black to black, and white to blue. Okay, so now we just have the AVR and the brushes, and the high voltage side should be done. So I'm just going to double check, make sure everything here is tight. Yeah, it's interesting too that there's a metal plate to hold the brushes in. You know, this generator seems to be very unique in that someone gave this a lot of thought. You know, it has a lot of things that I don't usually see pretty much everywhere I look. Including an AVR with a metal shell. So yeah, very unique machine. You know, even the valves, haven't seen anything like that before. All right, this is the connection for the DPE and the sense. Although it's not going together very well, so I'm going to double check the pins, make sure nothing is funny. No, that looks good. All right, looks like we're locked in. I'll connect this. And then we have the auxiliary winding, which is likely to charge the battery. Could also be for the fuel solenoid. Okay, and that's it down here. I'm going to leave this cover off for now. Let's get the tank on. So before we move on, I wanted to have a closer look at this oil sensor to see, you know, how it's designed and maybe figure out how it failed. You know, this one, it is different from the other two we looked at earlier because the other two had a contact where it picked up the engine ground and passed it on to the yellow wire when there was a low oil event. This one instead actually has this brass pin. So when the oil level gets low, you know, the float comes down with the pin until the pin contacts the crankcase, and that passes the ground signal to the yellow wire. So, you know, in theory, it's a pretty sound design. And if I test it, one lead on the yellow and the other one on this brass pin, we actually do get continuity. So I'm a little surprised that after draining the oil out, we didn't get a low oil signal. And actually, the failure here is that although this seems to function properly, if I hold the float in the down position like it is right now, and then I push up on the float moves separately from the pin. So the pin is still in the down position. The float is all the way at the top. So something failed, you know, allowing these two to move separately when they should actually be bound together. So, you know, we can have a quick peek in here. Potentially that'll give some insight as to what happened. And I've never actually looked inside of one of these, so, it's not clear to me what parts are missing other than, I think we should have a cap on the bottom, but that alone, I don't think is going to explain why the float and the pin are no longer connected. Okay, so the float, it's actually quite a bit larger than I thought it was going to be. And I do see a washer kind of on the top side, but it's not actually holding it in place. So it kind of makes me wonder if there's like an E-clip potentially that's missing on the other side. In fact, I think I might see a groove for it. So let's get this clip off. That will allow us to remove the float and the pin and just get a better look at the two. Okay, we get the clip. So I can pull the float off, as well as the pin. And yeah, we are actually missing an E-clip, so there should be another one right there. The one we pulled off was at the bottom. So yeah, that's not a good sign because I didn't see that when I cleaned out the engine. So I don't know if it came out in the oil change or if it already got chewed up. If that clip was there, then the float would be locked in, on both sides. So the float could not move separately from the pin. But yeah, without that clip, this will not function as designed. So I've got the battery and the handle back on, and I'm thinking, before adding the tank back, let's just try this real quick and make sure that the engine can stay running with that new oil sensor installed. So I've plumbed up the external fuel supply. So let's crank the engine and see what we get. All right, let's give this a try. The choke is on. I've got a light plugged in and turned on. Here goes nothing. Okay, good. Yeah, it started right up. Engine speed was a little fast, so I backed that off closer to 61.5 Hertz. And more importantly, the engine did not shut down, so I think the low oil sensor problem is fixed. So let's get the tank on, and then we can roll this outside and put it to the test. Well, I almost forgot, getting a little bit ahead of myself here. There was some old fuel in the tank, a little bit of rust. And I don't think the rust is enough to be that concerned about, but the old fuel is. That rust likely came from water. So potentially what's in the tank isn't actually fuel. So I'm going to get the fuel valve out. We'll just drain out what's left in the tank, mop it up, and then we can get this on the machine. Yeah, not much is coming out, but there is water in there. It's actually rust-colored water, so I might actually put a little bit of fresh fuel in here just to help kind of wash out any bits that might be loose in there. I'm just noticing too, there's no fuel filter on here. There should be a pre-filter to keep any rust that might be floating around in the tank. So this filter, although it might be good, I think I'm going to replace it. But for now, I guess we can just put it back in the tank and use it as a plug. But when we go to put this back on the machine, we'll get a new valve installed with a fuel filter. So the fuel I'm going to put in here, it's still good fuel, but I did pull it from a machine that, I would say the fuel is a little bit past its fresh date, so I'd rather use it to clean this tank than throwing it in another machine. I'm going to take a look with the borescope, which I'm kind of thinking I shouldn't, because I'm probably going to see stuff I don't like. The fuel valve is actually on the other end of the tank, and that's the lower end of the tank. What we were looking at was the higher end, and that's why it looked like there wasn't a whole lot of rust. But based on what I'm seeing coming out, I'm thinking there might be a little bit more rust in there than I initially thought. Yeah, it actually looks pretty good in here. So we're looking kind of down the length of the tank at the top of the tank, and that actually rusts up usually first because the moisture comes out of the fuel, condenses on the top, and yeah, there is a little bit of rust right there. But yeah, overall the tank actually is in really good shape. So I'm not too worried about that. But I am going to rinse the tank just a little bit more. And it's pretty important to get the water out. So after this rinse, I'll probably just tip the tank up on its side lengthwise so that any remaining fuel and water just goes to one end. And then we'll mop it out the best we can. It's kind of small opening too, so it doesn't lend itself too well to being cleaned. Pretty dry. So we'll get the new fuel valve and filter in. On Honda clones, there's usually only two types. It's either internal thread like this one or external. So this one is very similar to the one we pulled off, except we have this little fuel filter right here, which doesn't seem like a lot. But if you get debris in the tank, you know, this will prevent it from going down into the carburetor. And just to give you a better look at what came out, so, you know, majority of the fuel is what I added, and this rust-colored stuff here on the bottom, that is actually water. You know, that is what caused the damage to the tank. So it's critical that you get water out of the tank before it destroys it, and of course, that will damage the carburetor and also prevent your engine from running. And now we need to resecure these. So usually you zip tie them right to there, but in this case, they actually zip tied this bundle to that bundle, which prevents these wires from falling in. So the real trick here is going to be, you know, just getting the cover back on, because there are quite a few wires in one spot. I think something like that will do. Although ideally, I'd probably keep this all away from the high voltage side of things, but that is not how it was designed, and I don't think we could fit it even if we wanted to. All right, so let's put this thing to the test. I'm going to get the engine started. While it's warming up, we'll use the kilowatt to measure the voltage in the hertz, make sure everything is good. We're also going to use the amp probe to measure the total harmonic distortion. Ideally, it would be 5% or less. That is considered safe for electronics. But on machines like this, usually you see in the mid to upper teens. So we will find out where this one comes in at. We also have the oscilloscope so we can see what the output looks like, and the load bank, which we're going to use to load this machine to the max of 7,000 watts, which it shouldn't have a problem doing. The engine, it is actually oversized. It is 439 cc's, which should be able to pull about 8,000 watts before it runs out of horsepower. Anyway, on this machine, as we saw earlier, it is a floating neutral. And when using it as a portable, you do want to bond neutral and ground together. So, of course, we could go into the power head and make that change. But in this case, I'm going to use a bonding plug. All this does is connect ground and neutral together. So when we get this machine started, initially without this plug, we're going to see that only one of these orange lights light up, indicating that the bond does not exist and that we have a floating neutral. But when I plug this in, we'll see both lights light up. And when using it as a portable, that is what you want. That's going to keep you safe. So if there is a fault where the live wire touches the frame, the current has somewhere to go and the circuit breaker will trip. So let's get the engine started and see how it does. All right, so far so good. The engine's been running for a few minutes without any kind of a shutdown. Without a load, we're at about 5.1%, and the sine wave doesn't look terrible. So let's put on a half load of 3,500 watts, starting with 2,000 watts, 3,000, 3,500. So it looks like we're holding at about 59 Hertz. THD jumped up quite a bit, 21%, and the sine wave not looking too good. So we'll give this a few minutes, then we'll go for the max of 7,000 watts. All right, it's been a few minutes at half load. Everything's holding nice and steady. The voltage is very good. Engine speed is also decent as well. So let's swap some of these lighter loads and bring it up to 4,000 watts. Let's try 6,000 watts. Got quite a bit louder. How about 6,500? 7,000. Yeah, it's actually struggling to maintain 7,000 watts. The THD came up to 22.5. The sine wave looks about the same. So let's give this a few minutes and see if it can maintain this load. So the engine speed, it's kind of slow under this load, so I don't know if we're out of horsepower. No, we're not out of horsepower. So it's a governor sensitivity issue. So I'm going to take the load off and we'll make an adjustment on the governor sensitivity and see if we can improve that. Ideally, it would stay above 57 Hertz under that kind of a load. So it's a pretty tight space in here with the tank installed, and things are pretty hot, so I'm not sure how well this is going to go. I might need to wait for things to cool down, but I'm going to start by taking the spring tension off, and there is another hole where the spring connects to the governor arm. That hole is closer to the shaft, so it's going to make things more sensitive. You know, it might make it too sensitive, so we might have the opposite problem where it creates surging. But let's give it a try. We got nothing to lose. Okay, we've got the spring in. I'm going to bring up the tension a little bit, but we need to start the machine again to dial in that no load speed to 61.5 Hertz. Okay, so we've got the engine restarted. The engine speed's also been reset to 61.5 Hertz with the spring in the inner position, so the sensitivity should be a little better, but hopefully it's not too sensitive, causing surging. So right there, we're at a half load. The engine speed's about the same, I think, as it was before under that kind of a load, which is 59.1 Hertz, which is actually fine. You know, what we want to see though is that under a full load that we stay above 57 Hertz. So let's bring this up some more. So right there we're at 4,500. Let's try 6,500. Yeah, very similar to before. So we're at 6,500 watts. We can go up to 7,000. And it's trying, but it is a little unstable. So the engine speed did come up close to 57, but still a little bit short of what we're aiming for. So in this case, there is no further adjustment we can do on the governor. Really, the only other way to combat this is a little bit of more speed without a load. So I'm going to bring that up maybe closer to 62 and a half, and then we'll do the same thing and just make sure we're staying above 57 Hertz under full load. Alright, so now without a load we're at about 62.5 Hertz. So let's bring the load up and see if we can stay above 57 Hertz. So there's 4,000 watts, 6,000 watts, 6,500. See, the engine speed is fairly stable, but when we go to 7,000, that's where the engine gets a little unstable. It's right at the edge of what it can do, but now we're actually holding an acceptable engine speed, about 57.3 Hertz. So that is a lot better than where we were. So let's take the load off and let things cool down before we shut it down. Well, the good news is that used oil sensor, it's working quite well, which is more than I can say for that brand new one I got from eBay, or even the one we pulled out of this machine. So the big question is, was it worth it? And I would say no. You know, if you have a machine with a bad oil sensor, probably the easiest thing you could do is just check the oil periodically and forget about fixing that sensor. You know, it's not that the part is expensive, but the labor to replace it would be cost prohibitive. So unless you're doing this work yourself, it doesn't really make sense to try to make this repair. You know, as far as the load test goes, it was disappointing on several fronts. I guess first off, the total harmonic distortion. You know, we were over 20% under full load, which isn't great, but fairly typical for machines like this. The big surprise was the engine under load. You know, it got very loud with a full load. The engine speed became unstable between 6,500 and 7,000 watts, and the engine slowed to an unacceptable level. You know, ideally, this would be at 60 Hertz all the time, but with a mechanical governor, it's gonna sag or droop under load. So that's why you have to set the engine speed fast under no load. And really what you're trying to do is keep above 57 Hertz under full load, which we weren't. So we adjusted the governor sensitivity. That helped a little bit, but it didn't quite get us over the finish line. So we bumped that no load speed up to about 62.5 Hertz. And like that, we stayed above 57 Hertz under a full load of 7,000 watts. Now, I guess the last thing I want to mention here is that the engine should have done that without issue. It's rated for close to 8,000 watts. So, you know, I was kind of scratching my head wondering about that. Like, do we have more problems with the engine than I know about? And I guess the short answer is we actually were pretty close to 8,000 watts. You know, these labels here, they assume 120 volts, which we weren't. We were at about 126. So once you factor that in, plus the 200 watts for the cooling fans, 100 watts for the light, you know, we're a lot closer to 7,700 watts instead of the 7,000 that we thought we were pulling. So that does make a lot more sense. We were kind of at the limit as far as what this machine can do. So I hope this video helps someone. Thanks for watching.